dipoles, questioning dotted like short and pattern. So this in two short dipole pk cap, p by 2 k cap. Okay. So there is no doubt as to in which direction the dipoles are pointing. Dipoles are pointing along z axis. S are located at what? 0, 0, 0, that is at the origin, and one of them at 1, 0, 2 in the xz plane. Okay, then the resultant electric field due to the two dipoles at 1, 0, 0. Three-dimensionally ಯೋಚನೆ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. Yes, if it is a two-dimension, it is very easy. Three-dimension means okay. Let's try what is. Okay, 0, 0, 0, if it is here, one, 0, 2 ಎಲ್ಲಿರುತ್ತೆ? 1, 0, 2, somewhere here. So the dipole moment of this is what? P. What is the dipole moment for this? P by 2. So dipole moment for this is P. The dipole moment for this is P by 2. Okay. Then the resultant electric field due to the two dipoles at a point, where is it? 1, 0, 0. 1, 0, 0 under somewhere here. So 1, 0, 0 lies on which axis? X axis. Yes. Okay. And what is the position vector of this? The position vector of this is what? 1, 0, 2. What is the position vector of this? The position vector of this is 0, 0, 0. Okay. And what is the position of this? This is 1, 0, 0. Okay. See, for this P by 2 vector also x coordinate is 1, and for this point also x coordinate is what? 1. Okay? So P by 2 ಅನ್ನೋ ಡೈಪೋಲ್ ಗೆ ಈ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ? ಆಕ್ಸಿಯಲ್ ಪಾಯಿಂಟ್ ಆಗುತ್ತೆ. It is lying because ಎರಡಕ್ಕೂ x same ಇದೆ. Yes, ಎರಡಕ್ಕೂ x same ಇದೆ ಅಂದ್ರೆ if you draw like this, x is equal to one line, both of them will lie on the same x is equal to one line. Yes, ಯಾಕಂದ್ರೆ for this point also x is 1, for this point also x is 1. So if you draw a straight line which represents x is equal to 1, This dipole and this point, both of them will lie on the same line. So if it is lying on the same line, E point in agate, E dipole ge axial point agata. Yes. Okay. And what about for this dipole? For this dipole, because it is a short dipole, can we take that this is an equatorial point? Yes, short dipole iddaga a dipole ge hinge hodre it will be equatorial point. So for this P, this is equatorial point. For this P by 2, this is what? Axial point. Okay, what is this distance? What is this distance? This distance is 1 meter. What is this distance here? Between this dipole and this point, E distance is there. You are going along Z axis. This is 2 meters. So E dipole in the E point ಎಷ್ಟು ದೂರ ಇದೆ? It is at a distance of 1 meters, and from this dipole, this point is at what distance? It is distance of 2 meter. Direction ಇವಾಗ find ಮಾಡಬೇಕಲ್ಲ. ಈ point ಮೇಲೆ because of this P and this P by 2, it will be same or opposite direction. Axial point ಅಂದ್ರೆ P direction ಅಲ್ಲಿ ಅದು ಇದೆ. Okay. Equatorial point ಅಂದ್ರೆ P direction ಹಿಂಗ್ ತಗೊಂಡ್ರೆ ಅದರದು opposite direction. Okay. P direction ಏನಿದೆ ಅಂತ ಇಲ್ಲಿ ಗೊತ್ತಿದೆಯಲ್ಲ. So because of this P, it will be minus K cap, and because of this P by 2, it will be plus K cap. Okay. So for P by 2, point is what kind of point? Point is axial, and distance is how much? Distance is 2 meters. Okay. And then for P, point is what? Point is equatorial, and the distance is how much? And the distance is 1 meter. Okay. Option 2. Okay, let's see. Electric field because of P by 2 ಏನಾಗುತ್ತೆ? Axial point ಇರೋದ್ರಿಂದ it will be 2 kp. P is P by 2 divided by R cube. Yes, sir. It is 2 kp divided by R cube. R cube. What is the distance? R is 2 meters. R is 2 meters. In the 2 cube ಮಾಡಿದ್ರೆ it ಏನು ಬರುತ್ತೆ? 8. And what is the direction here? The direction is K cap. The direction is K cap. ಯಾಕೆ direction K cap? ಯಾಕಂದ್ರೆ P by 2 the direction K cap ಇದೆ. So other direction ಅಲ್ಲಿ electric field ಇರುತ್ತೆ. So it will be K cap. Now what will be the electric field because of P? Minus Kp divided by R cube. Minus Kp divided by R cube. Minus Kp divided by R cube is 1 cube is 1. Add these two. Net electric field. Net electric field will be Kp by 8 minus Kp. ಎಷ್ಟು ಬರುತ್ತೆ ಇದು? Kp by 8 minus Kp is so this is net electric field is equal to minus 7 by 8 K na ನೀವು 1 by 4 pi epsilon naught ಅಂತ ತಗೊಂಡ್ರೆ 8 4s 32. So the net electric field you are getting it as minus 7 P divided by 32 pi. Option B. Very good. Option B. Okay, try and visualize this as much as you can. At point P, the dipole is in this direction, and this point becomes axial point at the origin dipole ge. This will become equatorial point. Any doubts in this? Yes? We'll look at the next one. Okay. Directly tell me. Total electric force on an electric dipole placed in an electric field due to a point charge. Due to a point charge, electric field uniform irutta. Due to a point charge, electric field uniform irutta. No, from point charge, electric field varies as what? Electric field varies as 1 by r square. Yes or no? So if you have a point charge here and if you have a dipole here, okay, what happens? So this minus q and this plus q both will be at different points, so which means the net force on this will not be equal to 0. Okay, because due to a point charge, due to a point charge, electric field is what? Electric field is non-uniform. Electric field is non-uniform. So again, you can argue that, sir, if we keep this dipole far away, from this positive charge, then our uniform electric field iruttala. Then net force 0 and then hoda. Okay. My argument is, yes, you can say that net force will be 0 if this dipole is quite far away from point charge. So maybe 0 annadenu kottilla. So what does it say? It says always 0 antu enak sadhya illa. Yes, never 0. Yeah, this is possible. What are option C? 0 when the midpoint of dipole coincides with the point on the charge. No. Why will it not be 0? So let's say this is the point charge and dipole ee ತರ ಇದೆ, minus q illide and plus q illide. Okay. And this positive charge is at the middle of these two. So net force on dipole 0 agutta. See here, on this there will be attractive force towards right, on this there will be repulsive force towards right. So the net force the net force F plus F, it is becoming what? 2F. Yes. So if point charge on you dipole nadabarkitre enagutte, on the dipole the force will not become 0. Okay, it is 0 when the dipole axis is along what? Any electric line of force. No, if it is along any electric line of force, this is the positive charge, electric line of force hingide. Okay, ಅವರು ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಆಪ್ಷನ್ ಡಿ ಅಲ್ಲಿ ಡೈಪೋಲ್ ಕೂಡ ನಾವು ಈ ತರ ಇಟ್ಟಿದ್ದೀವಿ, ಡೈಪೋಲ್ ಕೂಡ ನಾವು ಈ ತರ ಅಲಾಂಗ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಲೈನ್ ಆಫ್ ಫೋರ್ಸ್ ಇಟ್ಟಿದ್ದೀವಿ. ಅವಾಗ 0 ಆಗುತ್ತಾ? No, this minus q will be near this and this plus q will be away from this. ಏನಾಗುತ್ತೆ? net force in this case will not come out to be 0. Okay, so the only possible answer here is it is yes. We have a positive charge, this is minus q, this is plus q. Minus q is nearer to this plus positive charge and this plus q is away from this positive charge. Here if it is minus e q into e1, here it will be plus q into e2. ಎರಡು ರಿಸಲ್ಟೆಂಟ್ ತಗೊಂಡ್ರೆ 0 ಬರಂಗಿಲ್ಲ. That's what we have talked. If an dipole is placed in a non-uniform electric field, what happens? Net force nu irutte, net torque nu irutte. And point charge uniform electric field form ಮಾಡುತ್ತಾ? No. Point charge idre electric field varies as what? 1 by r square. Okay. You already done this? Yes. Dipole ಇಂದ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ electric field perpendicular ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ the angle is tan inverse of root 2 and it forms what? It forms a straight line. ಈ ತರ dipole ಇದ್ರೆ ಯಾವ angles so for all of these points electric field is what? Electric field is perpendicular to the dipole. Electric field is perpendicular to the dipole. Okay. Then this is also easy. Should be. An electric dipole is placed in an electric field generated by point charge. Okay. Yeah. Now the net force on dipole never be 0. The net force on dipole may be 0. Okay. The torque on the dipole due to the electric field must be 0. No. Option D is the torque on the dipole due to the electric field may be 0. Yes. The net force on the dipole can never be 0. The net force on dipole may be 0. As I said, if you take that the dipole is very far away from the point charge, electric field because of the point charge almost uniform anta tagotide. Almost uniform anta tagondag enagutte? Net force at that time on the dipole becomes 0. Okay. Okay. Let's see you try these questions. Please write down this question. So all of these questions in this series, they not all of them. There are tricks for some questions, although they are difficult. Flux through a circle in a region. So what are we trying to calculate? We are trying to calculate flux through a circular area. Flux through a circular area in a region. An electric field exists in a given direction and it passes through a circle of radius r normally. Okay, normally andre if you have a circle like this, then the electric field is normal to the circle. Let's say you have this is the circle, electric field is what? Electric field is normal to the circle. Okay. Then what are they saying? The magnitude of the electric field is given as E is equal to E naught 1 minus small r by capital R. Okay. Where R is the distance from the center. Find the electric flux passing through the plane of the circle within So it's a uniform electric field or non-uniform electric field? Non-uniform electric field. Non-uniform electric field, how is it varying? Okay. So if I take a circle like this, we'll do the front view first. Okay. So if the circle is in this plane, how is the electric field? Electric field is normal to this plane. Okay. Then how is the electric field varying? Electric field is varying with radius like this. Electric field is varying with a radius like this. So what is the electric field at the center? What is the electric field at the center? Centrally R is equal to what? 0. So at the center electric field is what? E naught. Yes. So at the center electric field will be E naught. At R by 4 electric field yesterday at a distance of R by 4, what is the electric field? You simply put R is small r is equal to capital R divided by 4. So capital R divided by 4 andre 1 minus 1 by 4 anta barutte. So this will be E naught into 3 by 4. So that will be 3 E naught by 4. What is the electric field at R? Electric field is what? Electric field will be 0. That means the electric field is varying radially outward like this. Yes. So if I take a circular area, okay, if I take a circular area, small circular area at R distance, okay, I will take this small circular area. What is the distance of the circular area from the center? The circular area from the center has a distance of R, okay, and the length of this, let's say it is dr. Electric field on this entire area is constant. Yes, sir. So ee tara nanu ondu circular ring tagonde. Okay, if I take a circular ring at R distance, ee ring mele electric field constant irutta? Yes or no? Yes, because every point on this ring is at the same distance R, which means at every point on this ring the electric field will be same. Say for example, if I want to calculate what is the electric field on the edge, what is the distance of the edge from the center? R. So what is the electric field here? 0. Yes. So if I ask what is the electric field here? 0. What is the electric field here? 0. What is the electric field here? 0. So on this ring the electric field is 0. Ade riti on this ring what will be the electric field value for a small element? Right. So we are taking a small elemental area here, and for that small elemental area which is at R distance from center, what is the electric field? The electric field will be equal to E naught into 1 minus small r divided by capital R. Yes or no? Yes. For this entire small area, the electric field is constant. Now, what will be the flux through this small area? Yes. Now, area vector, area vector is electric field is also in the same direction. So cos of A, this will become E into dA into this will become cos 0 degree. Okay, so what cos 0 degree will be 1. So flux through this small area, will be E into dA. Okay. E is how much? E is E naught into 1 minus small r divided by capital R into what is the area of this? Yes, area of this 2 pi r into dr. Yes, we have seen this. How do you write the area of this? You will write it as 2 pi r into what? Dr. 2 pi r into dr. Either length 2 pi r and the width dr. Okay. So if you want the total flux, it will be what? Integration of this small flux, which will be equal to integration of E naught into, or you do 2 pi E naught into 1, or this is r minus so if you want this total area, ಈ dr ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ವೇರಿ ಆಗಬೇಕು? From r equal to 0 to r equal to capital R. So this dr is varying from 0 to capital R. So if you do the integration here, what do you get? You get flux phi is equal to 2 pi E naught into ಇದರದ integration ಏನಾಗುತ್ತೆ? R square by 2 minus ಇದರ integration ಏನು? R cube divided by and ಎರಡರದು ಲಿಮಿಟ್ಸ್ ಏನು? 0 to capital R. Okay, lower limit is 0, so 0 ಹಾಕಿದ್ರೆ ಅದು 0 ಆಗುತ್ತೆ. ಓನ್ಲಿ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಹಾಕಿದ್ರೆ ಏನು ಬರುತ್ತೆ ವ್ಯಾಲ್ಯೂ ನೋಡೋಣ. ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಹಾಕಿದ್ರೆ ಏನು ಬರುತ್ತೆ ವ್ಯಾಲ್ಯೂ? ಇದು R square by 2 minus R cube by 3. So R square by 2 minus R cube by 3 will be R square by 6. It will be R square by 6. So therefore flux will be equal to what? 2 pi E naught into R square divided by 6. So 2 and 6. So you will get what? Okay. The important thing to understand here is electric field is varying radially outward like this. Okay. So because it is varying radially outward like this, the elemental area I took was this small ring. Okay. If it was varying like this horizontally, ಅವಾಗ ಯಾವ ತರ elemental area ತಗೋಬೇಕಾಗುತ್ತೆ? You would take an elemental area like this. So let's say if the electric field is varying from bottom to top, right, you will take a small strip here. Okay. ಈ ತರ ತಗೊಂತಾ ಇದೀವಿ ಅಂದ್ರೆ ಏನು? ಇದು ಲೆಫ್ಟ್ ಟು ರೈಟ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ. ಲೆಫ್ಟ್ ಟು ರೈಟ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಮೇಲೆ ಮೇಲಿಂದ ಕೆಳಗಡೆ ಹೋದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸೇಮ್ ಬರುತ್ತೆ. ಅದೇ ನಾವು ಹಾರಿಜಾಂಟಲ್ ತಗೊಂಡ್ರೆ ಏನರ್ಥ? ಹಾರಿಜಾಂಟಲ್ ಸ್ಟ್ರಿಪ್ ತಗೊಂಡ್ರೆ ಏನರ್ಥ? ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಹೋಗುವಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸೇಮ್ ಇರ್ತಾ ಇದೆ, ಬಟ್ ಬಾಟಮ್ ಇಂದ ಟಾಪ್ ಹೋಗುವಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ. ಓಕೆ. ಸೊ ಯಾವಾಗಲೂ ಎಲಿಮೆಂಟಲ್ ಏರಿಯಾ ಯಾವ ತರ ತಗೋಬೇಕು ಅಂದ್ರೆ, ಸೊ ಇಫ್ ಯು ಆರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಲೆಫ್ಟ್ ಟು ರೈಟ್, ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಎಲಿಮೆಂಟಲ್ ಏರಿಯಾ. ಇಫ್ ಯು ಆರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಟಾಪ್ ಟು ಬಾಟಮ್, elemental area should be perpendicular to that. So if you are going radially outward, what will be the area perpendicular to that? The area perpendicular to that will be this ring. Yes. So ಯಾವಾಗಲೂ ಯಾವ ಡೈರೆಕ್ಷನ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ ಆ ಡೈರೆಕ್ಷನ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಎಲಿಮೆಂಟ್ ತಗೋಬೇಕು. Okay. So if you are going from left to right, the area has to be taken perpendicular. If you are going from bottom to top, the area has to be taken horizontal. If you are going radially outward, the area radially outward ಗೆ perpendicular ಏನು ಬರುತ್ತೆ? ಸರ್ಕಲ್ ಆದ್ರೂ ಬರುತ್ತೆ ಅಥವಾ ಸ್ಫಿಯರ್ ಆದ್ರೂ ಬರುತ್ತೆ. ಎಸ್. Okay. Shall we look at next one? ನೋ ಕೂಲಮ್ಸ್ ಲಾ ಓದುವಾಗ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಆಫ್ ರಿಂಗ್ ಮೇಲೆ ನಾವೊಂದು ಕ್ವೆಶನ್ ಮಾಡಿದ್ವಿ ಹೌದಾ. ವಾಟ್ 2 ಡೆಲ್ಟಾ ಟಿ is equal to what did we do? 2 delta t f ಅಂತ ಮಾಡಿದ್ವಲ್ಲ. So what was the formula for delta t that we got from there? Radius, this ring r is equal to 0.1 meters. The ring is made of thin metallic wire whose area of cross section, okay, this is a thin metallic wire whose area of cross section andre illi area of cross section ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Area of cross section, let's see, yes, is equal to 10 power minus 6. What does that say? The ring has a uniform charge of 5 coulombs. The ring has a uniform charge of what? 5 coulombs. And then what does it say? Find the change in the radius of the ring when a charge of 10 power minus 8 coulomb is placed at the center of the ring. Okay, at the center of the ring, what are we doing? At the center of the ring, we are placing another charge q, which is equal to how much? Which is equal to 10 power minus 8 coulomb. And let's say this is capital Q. Okay, tension value ಏನು ಬಂದಿದ್ದು? KQ okay. So did you understand what is happening in the question? Yes, metallic ring ಇದೆ. Okay, metallic ring ಮೇಲೆ positive charge place ಮಾಡಿದ್ರೆ how much is that? 5 coulomb. ಈ ಮೆಟಾಲಿಕ್ ರಿಂಗ್ ನಡುವರ್ಕ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ? Another plus q charge they are placing. What is that plus q charge? That is 10 power minus 8 coulomb. ಏನಾಗುತ್ತೆ? Between this ring and this charge there will be a force of repulsion. Okay, so what will happen to this ring? This ring will try to expand. Yes, or expand ಆದಾಗ ಏನಾಗುತ್ತೆ? Tension create ಆಗುತ್ತೆ. Yes, no, from that tension what are they asking you to calculate? They are asking you to calculate what is the result. Okay, find the change in the radius of the ring. What else they've given? They've given Young's modulus. So what is the formula for Young's modulus? Young's modulus is what? Okay, then stresses ಒಂದು ಹೊಡೆಯೋದು ಅದ್ರ ಮೇಲೆ ನೀವು ಫೋರ್ಸ್ ಹಾಕಿ ಇರ್ತಾ ಇದ್ದೀರಾ and then shrinking. So what is happening? Force divided by area. What is this area? Cross section area. Yes, force divided by area divided by strain. Strain is what? Change in length divided by original length. So ಈ ಕೇಸಲ್ಲಿ expand ಯಾಕೆ ಆಗುತ್ತೆ? Because this tension is developed in the ring. So this tension is the force which is creating that expansion. Yes, now from this formula you can calculate the tension. Yes, area of cross section they've already given. How much is the area of cross section? Area of cross section is given as, okay, so Young's modulus alli this is given, this is given. Then what is happening to this? Because of this tension force its size is increasing. Okay, delta L by L ಹೆಂಗ್ ಬರೀತೀರಾ ಇದರಲ್ಲಿ? Initially, what is the length? Yes. So let's say radius r iddiddu, it increased to r plus delta r. Let's say it has increased from r to r plus delta r. So r plus delta r adaga, what is the length of this ring? Huh? New length will be equal to what? 2 pi r plus delta r. Now what is the value of delta L now? Change in length? Yes, change in length is 2 pi r plus delta r minus 2 pi r. This is 2 pi delta r. So if you find what is the value of delta L by L, delta L by L is coming out to be delta L is coming out to be delta R divided by R. So can I write this formula? Young's modulus is equal to what is the force? Force is the tension divided by cross section area S divided by delta R by R. Sorry, delta L by L. Can I write it as delta R divided by R? So question ಅಲ್ಲಿ ಏನು ಕೇಳಿದ್ದಾರೆ ಅವರು? They are asking what find the change in radius. Change in radius ಅಂದ್ರೆ ಏನು? Change in radius ಅಂದ್ರೆ delta R R delta R. So from this formula, how do you find delta R? T into R S divided by Y into S. T into R divided by Y into S. Okay. So this ring, because of repulsion, instead of R radius, it is becoming R plus delta R radius. Okay. So yaak aagta ide? Because of tension. Okay, this tension already we have calculated earlier. It is KQQ divided by 2R square. Is that correct? Huh? Okay. Then Young's modulus ಏನು ಹೇಳುತ್ತೆ? Young's modulus ಏನು ಹೇಳುತ್ತೆ? It is stress divided by strain. Okay, stress divided by stress is force per unit length divided by strain is delta L divided by L. Okay. What is the force which is increasing its length? Tension is the force which is increasing its length. Divided by cross section area of that wire already given. Okay. Delta L by L. L is 2 pi R. What is the new length? 2 pi R plus delta R. So delta L ಏನಾಗುತ್ತೆ? Delta L will be 2 pi delta R. So delta L by L is actually coming out to be what? It is coming out to be delta R divided by R. So instead of delta L by L, I can replace it by delta R by R. So from this formula, I can write that delta R is equal to what? T into R divided by Y into S. T into R divided by Y into S. What will be that? T is what? KQ to Q. That is K is what? 9 into 10 power 9 multiplied by Q is pi coulomb. Pi coulomb anta idala. Pi multiplied by small q is 10 power minus 8 divided by 2r square, that is 2 into r is 10 power minus 1 andre idenagutte 10 power minus 2 t into r. What is the value of r? R value is 10 power minus 1 whole divided by y into s. What is the value of y? Y is given as 2 into 10 power 11 multiplied by what is the value of s? Yes. Huh? 10 power? Yes, yes. What is yes? Yes, yes. Cross section area. Cross section area is given as 10 power minus 6. Okay. Do you get 2r square or 2 pi r square? Is it 2r square or 2 pi r square? So I think this formula is 10 power 1, 10 power minus 1 is gone. 10 power 4. This is what, 10 power 5. 10 power 5. 10 power minus 7 ಬರ್ತಾ ಇದೆಯಾ? K Q1 Q2 by 2 pi r square into radius r. R is 10 power minus 1 divided by y into s. Okay. So 10 power 11, 10 power minus 8 will be 10 power 4. And so this will become 10 power minus 3. Yeah? 8. Yeah. 10 power minus 3. 9 by 4 into 10 power minus 3. 9 by 4 is what? Okay. Yeah. So this is coming out to be 2.25. 10 power minus 3 is milli. So delta R S ಬರ್ತಾ ಇದೆ, delta R S ಬರ್ತಾ ಇದೆ 2.25 millimeter. 2.25. Okay, this tension is actually K Q1 Q2 divided by 2 pi r square. Huh? Sin theta by 2 divided by theta by 2. Okay.